Okay, now we're going to discuss exponent rules and scientific notation. And a quick review of the difference between the base and the exponent. If I asked you to evaluate 2 to the power of 3, that means I'm asking you to multiply 2 3 times. So that means 2 times 2 times 2, which is 8. Be careful. A lot of people will do a quick evaluation and not think it through and say 2 to the 3 is 6 because they think 2 times 3 is 6. But 2 to the third means you take 2 and multiply it 3 times. 2 is what's called the base. That's what you're multiplying. And the exponent is what tells you how many times to multiply the base. And so the exponent rules tells us how to handle expressions that have exponents in them. So the product rule says if we have a product where the bases are the same and we want to multiply, we would get x to the m plus n. You keep the base the same and you add the exponents. So for example, if I had 5 to the third times 5 to the seventh, the base stays the same, and I would write that as 5 to the 10th because I add the 3 and the 7. Now, if I had 5 to the third times, say, 2 to the 7th, I cannot rewrite that. Actually, let me do this. This does not equal 10 to the 10th because I can't take the 5 times the 2 and then add the 3 and the 7. You cannot do that. The bases have to be the same in order for this product rule to work. So this is a common mistake. When you're multiplying, you keep the same base and you just add the exponents. The quotient rule says if you're dividing and your bases are the same, then you keep your base the same and you subtract your exponents. So, for example, if I had 5 to the 8th over 5 to the 6th, I would keep my base the same, which is 5, and I would take 8 minus 6, which would give me a 2. The power rule says if you have an exponent that's being raised to another exponent, then you multiply, you keep the base the same and you multiply the exponents. So for example, if I had 5 to the 7th and I raised that to say the 8th power, that would be 5 to the power of 56 because I multiply the 7 times the 8 and keep the base the same. If you have a base that's raised to the power of 0, that's always going to be equal to 1, except if the base is 0, then it's undefined. You can't have 0 to the power of 0. Now, the reason why anything raised to the 0 power, except if the base is 0, is equal to 1 is because of the quotient rule. If I take x to the third over x to the third, we know when we have a fraction and the top and the bottom are the same, that's division. So I'm taking x to the third divided by x to the third. That's just going to give me 1 because it's the same on the top and the bottom. But if I use my exponent rule, which is the quotient rule, my base would stay the same and I would subtract my exponents. So I would have 3 minus 3, which is 0. So these two statements are equivalent. So for example, if I had 5 times 7 times x to the third, and that's all raised to the 0 power, as long as x is not equal to 0, that whole big mess would be equal to 1, because this is all being raised to the power of 0. Negative exponent rule also stems from the quotient rule. So for example, if I had x to the third over x to the fifth, we know using our understanding of fractions that x to the third is x times x times x, And x to the fifth is x times x times x times x times x. And with fractions, we know we can cross off anything that's the same on the top and the bottom. So if I cross off 3x's that's the same on the top and the bottom, then I would have 1 over x squared, because I would have these two x's left downstairs. If I use my quotient rule, I would keep my base the same and I would subtract my exponents. So I would have 3 minus 5, which would give me a negative 2. So the negative exponent rule says if you have a negative as an exponent, you can make it positive by taking the reciprocal. So, for example, if I gave you 3 to the power of negative 2, I can rewrite that by taking the reciprocal of 3 and writing it as 1 over 3 with a positive 2. So negative exponents, if we want to make it positive, we take the reciprocal of the base. Okay, now using these rules that we just went over, we're going to practice simplifying the expressions. And we want to make sure that all of our exponents are positive when we write down our final answer. So this has an exponent raised to another exponent. I have a to the negative 2 times x. Even though we don't write it in there, we know that's to the power of 1. And I'm squaring that whole thing. So anything that's inside the parentheses that is an exponent, I have to multiply that by 2. When you raise a power to a power, you multiply the exponents. So that's going to be a to the negative 4, because we take negative 2 times positive 2. And that's going to give me a squared, because x to the first, I take that 1 times the 2, and that's going to give me a 2. Now, we're not completely finished, because we want to make sure that we write our answer with all positive exponents. So, in order to make that negative 4 exponent positive, I have to take the base and flip it upside down. I have to take the reciprocal of a. So instead of the a being upstairs, the a is now going to go downstairs with a positive 4 as the exponent. And now this will be our final answer. Our next example is x times x to the third divided by x to the negative 4. In the numerator, I can multiply, because those bases are the same, I can multiply x to the first times x to the third. And when you multiply and your bases are the same, you add your exponents. So that's going to give me an x to the fourth upstairs, and I'll just carry down the x to the negative 4 downstairs. Now, to finish this up, I can do this one of two ways. I'll use the quotient rule, but if you want to try a different way, that's fine. The quotient rule says if I'm dividing and my bases are the same, I subtract my exponents. So my base stays the same, and I'm going to take 4 minus a negative 4. So I have 4 minus a negative 4. That's going to make that a 4 plus 4, because it's a double negative, and I get x to the 8th. Now the other way you could have done this is you could have made that negative 4 exponent positive by taking the reciprocal. So if I rewrite this as x to the 4th over 1 times 1 over x to the negative 4, I could take the reciprocal of 1 over x to the 4th and make that 4 positive. That becomes that. And then use the product rule again and say, well, my bases are the same, so I can add my exponents, and I get the same answer. So for a lot of these, there's multiple ways to do them. As long as you do it correctly, you're going to still come up with the same answer. Okay, for example C, again, we're raising a power to a power. So inside, all of my exponents need to be multiplied by negative 2. So I have a to the power of negative 2 times negative 2, which is a positive 4. And then b in the denominator, when I take 2 times the negative 2, that gives me a negative 4. Now, because I have a negative exponent with that b, I want to take the reciprocal to make it positive. So I have a to the fourth times b to the fourth. Now, because these are not like bases, I can't combine those and add the 4s. They're different bases, so I have to leave it just like that. I can't go any further. Okay, the next example, we again have two bases, so we have to be careful and not mix up our bases. We can combine our a's and we can combine our b's, but we can't mix them. So I have a to the negative 2 over a to the fifth, and then b to the third over b to the negative 4. I'm going to separate them to make this a little bit easier. Using the quotient rule, because my bases are the same for the first fraction, a to the negative 2 over a to the fifth, I can rewrite that as a to the power of negative 2 and subtract 5. The quotient rule says I take the top exponent and I subtract the bottom exponent. Same thing with b. I'm going to take the top exponent and subtract the bottom exponent. So that gives me a 3 minus a negative 4. So that gives me a to the power of negative 7 times b to the power of positive 7, because I have a 3 minus a negative 4, that gives me a plus 4. So I have 3 plus 4, which is 7. Now to finish this up, I don't want to end up with negative exponents, so I'm going to take the reciprocal of a to the negative 7 and make that a positive 7. So instead of that a being in the numerator in the upstairs, that a is going to go downstairs with a positive 7. And here's my final answer. Okay, in the next example, I'm going to rewrite this. The denominator, I'm raising the 3 and the x to the power of negative 2. So even though we don't see it written in there, I know that's 3 to the power of 1 and x to the power of 1. So when I multiply my exponent by negative 2, I'm going to get 3 to the negative 2 and x to the negative 2. Something that I see a lot of students make the mistake, they forget to raise the number or the coefficient to the power of negative 2. So be careful and remember that if it's inside the parentheses, you still have to raise it to a power, even if it's a coefficient of x. Okay, now I'll separate this. I'll separate my bases just to see this a little bit more clearly. You don't have to do that, but I like to do it. Okay, now I have the quotient rule. So I have the bases of 3. So that means I'm going to have 3 to the power of, and I take 4 minus a negative 2. That's going to give me a positive 6 because I have a double negative. 4 minus a negative 2. Then next times x to the power of, and even though it's not written in there, I know that's a 1. So I'm going to take 1 minus a negative 2. So that's 1 plus 2, which would give me x to the third. Now, at this point, if you want to actually put that in on your calculator and see what 3 to the power of 6 is, that's totally fine. But I'm okay with you leaving it like that, because I'm just looking to see if you understand the exponent rules. But if you wanted to actually multiply it out and find out what 3 to the 6th was, it's 729. So you can write it either way. I'm fine with that. In example F, we have two fractions being raised to an exponent, and we're multiplying them together. So the first thing we want to do is raise everything in that first fraction to the power of negative 2, and then raise everything in the second fraction to the power of 2. And when you raise a power to a power, you multiply the exponents. So in the first fraction, I have 2 to the 0 times a negative 2. So I'm going to take that 0 and multiply it by negative 2, and that's still going to give me 2 to the 0. In the denominator, I have x to the third, and I'm raising it to the power of negative 2. So that's going to give me an x to the power of negative 6, because I multiply my exponents. For my second fraction, that's going to give me x to the 8th, because I take the 4 times the 2. And then in the denominator, I have 3 to the 4th, because I take the 2 times the 2. Now, the 2 to the 0, we know anything raised to the 0 power, as long as the base isn't 0, is going to be 1. So that 2 to the 0 becomes a 1, and I still have x to the negative 6 in the denominator. 3 to the 4th, you can leave it as 3 to the 4th, or you can write it as what it actually is. It's 81. Either way is fine by me. And now I want to make sure that my exponents are positive. I have that x to the power of negative 6 in the denominator. Since 6 in the denominator, if I want to make that exponent positive, I have to reciprocate it. So it's going to go in the numerator as x to the positive 6. And now I can combine those two x's by multiplying and using the product rule. Because my bases are the same, I can add my exponents. So I have 6 plus 3, which is 9. And so this will be my final answer. Okay, now if you notice, I put this one in here to remind you that anything to the 0 power is 1 as long as the base isn't 0. So if you look, this whole thing is not equal to 0. So when I raise that whole mess to 0, I just get 1. Now we're going to talk about scientific notation. And scientific notation is a way for mathematicians and scientists to conveniently write numbers that are in decimal form that are really, really big or really, really small. And it helps with calculations and makes them a little bit more simple. When you write a number in scientific notation, it's in the form where you have some number, we'll call it n, times 10 to some power, we'll call it e for exponent. And n is a number that has only one digit to the left of the decimal place. So, for example, 3.572 times 10 to the 8th is a number that's written in scientific notation because if you look, there's only one digit to the left of the decimal. Something that is not written in scientific notation would be something like this. 21.358 times 10 to the 11th. Notice that there's more than one digit to the left of your decimal, so that this is not considered scientific notation. It has to be one digit to the left of your decimal for it to be considered scientific notation. So in this first example, we have two numbers. It's written in standard form right now, and we're going to put it in scientific notation. I want to move the decimal so that it's right here. And that way I have one digit to the left of the decimal. So I want to write this as 7.95 times 10 to some exponent. Now, to figure out what that exponent is, I count how many places I move my decimal point. So I moved it 1, 2, 3, 4, 5, 6, 7, 8, 9 places. So this is going to be to the power of negative 9. Now I chose negative instead of positive because this is a very small number. With small numbers, you're going to have negative exponents. And with really, really big numbers, like in example B, you're going to have positive exponents for your scientific notation. So in example B, I want to put my decimal place right here so I have one digit to the left of my decimal place. So I want to write this as 5.12 times 10 to the power of, and right now my decimal place is here. Even though it's not written in there, we know since it's a whole number, it's going to be to the right of the last digit. and I count how many places I move my decimal. 1, 2, 3, 4, 5, 6. So this is going to be 5.12 times 10 to the 6th. Now going in the other direction, if I have something in scientific notation and I want to write it in standard notation, then what we're going to do is we're going to count our decimal places. Since this is a positive 8, we know this is going to be a really big number, so our decimal place is going to go to the right. So I'm going to count how many places I move over to the right. So we got to count 8 places. 1, 2, 3, 4, 5, 6, 7, 8. So this is going to be where my new decimal value is, which means it's going to be 9, 1 with 7 zeros. So it's going to be 910 million. For part B, because this is a negative exponent, I know this is going to be a really small number. So I'm going to move my decimal place to the left instead of to the right. So I'm starting here, and I want to move it 6 places to the left. So 1, 2, 3, 4, 5, 6. So my new decimal place is going to go here. So I'm going to have 0.0000893 will be 8.93 times 10 to the negative 6 written in standard notation. Okay, now I'm going to show you how you can use scientific notation to make calculations with really big numbers and really small numbers a little bit easier. So in example A, we have 6.73 times 10 to the negative 5, and then we have 2.91 times 10 to the 2. So what we do when we do calculations with scientific notation is we multiply these numbers together. So I take 6.73 times 2.91, and then I multiply the 10 to the negative 5th times the 10 to the 2nd together. So I do those separately. And that really helps because we can use our rules of exponents to then do the calculations with the base 10 numbers very quickly. So on the calculator, I'm going to put 6.73 times 2.91, and that's going to give me 19.5843. Then I do 10 to the negative 5th times 10 to the 2nd. Using my rules of exponents, I know that that's 10 to the power of negative 3. So when I put that together, I get 19.5843 times 10 to the negative 3. However, even though this is correct, it's still not in scientific notation. So the reason why it's not in scientific notation is because remember, in order for it to be considered scientific notation, there can only be one digit to the left of the decimal. So I need to rewrite that 19.5843 as 1.95843. And then because I moved the decimal place over to the left, I would have to change that negative 3 to a negative 2 because I moved it one space. So this is my final answer written in scientific notation. Even though this answer here is correct, the first answer, this answer here that I boxed in red is the answer written in scientific notation. Okay, the next example here, same thing, but now we have division. We have 3.2 times 10 to the 3rd divided by 5.7 times 10 to the negative 2. So I do the 3.2 divided by the 5.7, and that's going to give me a 0.5614. Well, let's round it to there. We'll round it to 4 places. That's going to give me 0.5614. And then to get my power of 10, I use my exponent rules, and I take 10 to the power of 3 divided by 10 to the power of negative 2. So I subtract because I'm dividing. So I have 3 minus a negative 2, which makes that 10 to the 5th. Now, because I want to make sure that this is written in scientific notation as my final answer, I want to make sure that I have one digit to the left of the decimal. So I'm going to rewrite this as 5.614 times 10 to the power of 4. Now this is written in scientific notation. So let me show you how you can check this on the calculator. Okay, now to check this on your calculator, if you want your answers to be written in scientific notation, what you're going to do is you're going to go to your mode button that is right here at the top of your calculator below the window button. And then what you're going to do is, mine is 2 lines down, but somewhere in your mode, you should see options for normal, which is the calculator's way of saying standard notation. Then you have scientific notation here. So I want to arrow over and hit enter to make sure that I'm blinking and I entered on scientific notation. Then I'm going to quit out and go back to my home screen. And then any calculation I do from here on out will give me the answer in scientific notation. So in example A that we just did, we had 6.73 times 10 to the negative 5th times 2.91 times 10 to the 2nd. So on my calculator, I'm going to put 6.73. And then the notation you want to use for scientific notation on the calculator is this double E that's right above your comma button. You're going to hit the second button first to access that double E. So I'm going to hit second and then the comma button. And even though it says a double E on your keypad, it's going to come up on your screen as 1E. And I think that the calculator company does that so that you can tell the difference between the letter E and scientific notation E. So that E represents the times 10 to the power of. So after that E, all we have to do is write the exponent. So since we're doing 6.73 times 10 to the negative 5th, I'm going to make sure after that E I put negative 5. So I'm telling the calculator I'm using scientific notation with the power of negative 5. Now, when you put in that negative 5, make sure you use the negative button and not the subtraction button, or else the calculator will yell at you. Then I'm going to hit times, and then I'm going to put in 2.91, and times 10 to the 2nd means I'm going to hit the double E, which comes up as 1E, and then I'm going to put in 2 for my exponent. And when I hit enter, it will give me my answer in scientific notation. So just like we did it by hand, we get the same answer as what the calculator gives us. So the answer is 1.95843 times 10 to the power of negative 2. Now for the second example, let's check that one too. The second example was 3.2 times 10 to the 3rd. So I'm going to use my double E, which comes up as a single E, for times 10 to the power of. So I'm going to put 3, and then I'm going to do divide by, and then 5.7 times 10 to the power of negative 2. So make sure that when you're using negative exponents, you're using your negative button and not the subtraction, or else you'll get a syntax error. Okay, I'm going to hit enter, and it's going to give me the same answer that we got by hand, although we rounded. But we said when we did it by hand, we rounded to 5.614 times 10 to the 4th. The calculator went out a little bit further. So that's how you use scientific notation on your calculator. Now, it will stay in scientific mode unless you go back in and change it to normal mode. So if you start doing calculations that don't have scientific notation in them, and just like if I want to do 9 times 25, Because it's in scientific mode, it's going to keep coming up and giving you your answer in scientific notation. If you want to get out of that and just figure out what 9 times 25 is without the scientific notation, you have to go back into mode and change it back to normal. So I would highlight normal and hit enter. And then when I go back to my main screen and I just want to do 9 times 25, it will give me my answer of 225 instead of 2.25 times 10 to the power of 2.